Welcome everyone to another tutorial. Today I'm going to be explaining the intuition behind the harmonic mean formula. Now the reason for this is I was going through brilliant.org and in algebra through puzzles, the harmonic mean was brought up, but I honestly could not understand it because they just showed the formulas and I looked online. The formula was not, the intuition behind it wasn't explained. I couldn't find the intuition at least. So after figuring out, hopefully this video can help some of you. If you're here, hopefully you're looking for the intuition. So let's just try. I have an outline. I already did the video once, so hopefully I know what to do. So let's start off. This is the harmonic. Excuse the bad handwriting. This is the harmonic mean. N divided by the reciprocal of the rates. Now, I also just want to add in, let me just quickly finish. Apparently, this is also applied to statistics. I'm not familiar with its use in statistics. I'm just going to be explaining it in accordance to rates, in regards to rates. So, hopefully, if you're here for statistics, maybe it might apply. Alright, so, this is a way of calculating your average speed traveled. Average speed traveled when using distances. Now, why is it distances? Well, let's just quickly back up a bit and do something that is fairly familiar. In the scalar form, this pen is running out, but let's just see if it works. Okay, so distance divided by time. That is the scalar form of speed is equal to distance divided by time, average speed. So, let's quickly calculate a little problem. Let's say 60 kilometers, you travel 60 kilometers per hour for 30 minutes. Then you travel 100 kilometers, not 120, 100 kilometers per hour for 30 minutes. So, what is your average speed? Well, let's see. We already know time. Due to the fact that we're dealing with kilometers in the distance, let's actually just quickly convert. So 0.5 hours, 0.5 hours. And the total amount of time traveled is the sum of those two, obviously. So 1 hour, which is nice. We have a denominator of 1 hour, which simplifies things. Now for distance. Distance, we are going to actually multiply the two. And that is because if you look at it in terms of like dimensional analysis, where you'd want to cancel the units, 60 kilometers per hour multiplied by 0.5 hours, the 2 hours, the hour here is in the numerator, here it's in the denominator, so when you multiply it, it cancels out, so you're just left with the distance. So it makes sense in that sense. Okay. 60 kilometers per hour multiplied by 0.5 hours. That gives you 30 kilometers. That's the total distance traveled for that one. 100 kilometers per hour multiplied by 0.5 hours. Total distance traveled there is 50 kilometers. So we just sum these up, put them in the numerator. Sorry, this is a little tedious, but I think it will help with the explanation if you see this. So 30 kilometers plus 50 kilometers, the sum of those two distances we figured out, divided by 1 hour, gives you 80 kilometers per hour because the hour is in the numerator, in denominator. So that's the calculating according to time. Now, I'm going to use these same rates, but I'm going to split it up. Instead of according to time, let's do it according to distance. So, you travel, or random person travels 60 kilometers per hour for, let's say, 100, let's say, or actually make it 120 kilometers. So you travel that distance for 120 kilometers. Then you travel that same 100 kilometers per hour, and you travel it for 120 kilometers. So it sort of would make sense if it's the same as the time, but it's actually not. And we can just quickly calculate the values. So here we know the total distance. So let's just add speed equals distance divided by time. We know the distance, but we now we don't know the time. So let's quickly add up the distance. We get 240 kilometers. How are we going to calculate the amount of time? Well, if we divide the 60 kilometers by 120 kilometers, then the kilometers will cancel out and we'll have the amount of time. Actually, sorry, you're not dividing 60 kilometers per hour by 120, you're dividing 120 kilometers by 60 kilometers per hour. That makes sense because it's 2. So, anyway, I'm going to do the calculation anyway. So, 120 kilometers divided by 60 kilometers per hour. And due to the fact that it's in the denominator, it will move to the top as everything cancels. So, we're left with 2 hours. Then over here, we have another 120 kilometers traveled divided by, but in this case, 100 kilometers per hour. And the same, in this case, it's 1.2 hours. So, now we can just quickly put it into our little formula here. So, we have 240 kilometers divided by 2 hours plus 1.2 hours. And that gives, what's the name? 240. Now, let's just quickly calculate that. Divided by 3.2, that gives 75 kilometers per hour. What did we get here? We got 80 kilometers per hour. So as you can see, splitting it up according to distance and time does cause a difference. You can obviously think about that intuitively because if you are traveling according to time, you can spend more time traveling at the fast distance. So it sounds non-intuitive at the beginning, but as you think about it, it sort of starts to make sense. So, let me just quickly check the outline, make sure I'm going according to it. Okay, so now, this is the important part about the harmonic mean formula. The distance doesn't matter. If you're calculating according to distance, it doesn't actually matter. You're calculating the mean rates. Now, I'll show it. I'll show how it works if you manipulate an expression and how you can actually get to that outcome. But if you actually just think about it, you're just looking at proportions. Anyway, let's move on to calculating it like that. Sort of wasting paper, but it's all right. So, I'm going to use this just to show how we are simplifying it into a sort of formula. So, we get 240 kilometers by multiplying the distance traveled by each one. Distance is this 120 kilometers. We get it by multiplying it by 2. So, we get 2 distance. I'm just subbing in algebraic values. And then, as you can see, we divide this distance by the first rate. Divided by the first rate. Then we add it, because this will give us our first amount of time, 2 hours. Obviously, this is just generalized. Then we'll do the second distance with the second rate. And that will give us our second time. So when we sum it, we get the total amount of time traveled for twice this distance. Now let's do some manipulation. Now, let's hope that I get this right. It would be quite embarrassing. Let's just see if this marker works. if I make a mistake here, 2 distance divided by, now we're obviously just going to change up the numerator, so we get dr over r. Okay, so that's obviously just so that we can actually add the two. Okay, we're going back to the previous one. Don't have any other markers, so yeah. I'm gonna actually move this one to the front, then it will look a little nicer. dr1 plus dr2. We cannot add them because they're different they're different rates. r1, r2. Now we can move this to the numerator. This is just some manipulation. So 2d r1 r2 divided by, now let's look. We have 2 terms in the denominator and 1 term in the numerator. The term in the numerator has the distance, and the 2 terms in the denominator both have the distance. So I'm just moving it up like that. We can actually just factor out distance. So it is 2 r1 r2 divided by the distance, and then r1 plus r2. So we are left with 2r1 r2 r1 plus r2. So you can see we can literally factor out distance. That shows that it is not useful. We can disregard it completely. As I said, you can just think about it in terms of you're just trying to calculate the amount of time traveled for a set amount, but provided that you're not using whatever you whatever you, if you divide this distance by these 2 distances by 2, you need to make sure you divide the numerator by 2. But at the end of the day, it will still give you the same mean. Alright, so now let's quickly actually look at now how the harmonic mean formula looks and how it's actually just the simplification. If only this had more ink. So, one way of writing the harmonic mean formula, if you are given 2 rates, is like this. Now this makes sense. Distance doesn't matter. So here we had 2 times distance, but since distance doesn't really matter, we can just throw it out. So we can treat it as a 2. Here we have distance in the numerator. Doesn't matter, throw it out, we can treat it as a 1. Remember, this has the coefficient of d, the constant multiplying d is 2. Constant multiplying d here is 1. So we can literally just keep it as 1 and a 1. And so now you see that just by translating this whole mess, we can actually just translate it to that. Now, the actual harmonic mean formula actually looks like this. This is separated. So the reason for this is you are keeping with that. This will just be 3 multiplied by the distance, even though the distance doesn't matter anymore. And then you'll just have it split up. Now the problem is you can only use the harmonic mean formula like this if it's split up equally. So if you have a rate traveled at, say, 30 kilometers, and another rate traveled at another 30 kilometers, and another rate traveled at another 30 kilometers, you'll notice these distances are all the same. you need to make sure that it has a 1-to-1 ratio. They must be the exact same when you split it up. But you can still use the intuition behind the formula to calculate it if it's not that. So let's say you have a rate and you travel by 45 kilometers. And you have another where you travel 50 kilometers. And just to mess things up, you have a third rate and you travel 150 kilometers. Well, the harmonic mean formula is not going to work because it's not equally spread out. But what we learned, we can actually literally just make our own formula. It won't be as nice looking, but we can just add up all these rates. So we just sum them up. So we have 45 plus 50 kilometers plus 150 kilometers divided by, now remember the distance is meant to be there. Distance can technically still be irrelevant. You can divide them all by 150 kilometers, but that's just, going a little bit too crazy. So we have the first 45 kilometers, and I'm just going to quickly do this for all of them. 45 kilometers. And we're going to divide them by each of the rates. So as you can see, it has the same sort of a look, but you will have to do more working out. In this case, I'm not going to work that out, but you can see how it looks. So at the end of the day, this is the harmonic mean. You can use it when you're calculating distances. If you have distances that have if the rates have different distances traveled, you might have to go make it a little bit more tedious and work it out like this. Otherwise, if the distances are all split up equally, if the total distance is split up equally, so let's say you have 6 rates, and then your total distance, let's say d, then each rate must be traveled by d divided by 6. That makes sense if you look at it like this: R1, R2, R3, R4, R5, and R6. You have a total distance traveled of d. If you want them each to be that, then you have d divided by 6, so that each of them are split up evenly. So hopefully this makes sense. Sorry if I spoke a little bit too much about it, but that's basically the harmonic mean. Very useful when calculating average speeds according to distances. Apparently also statistics. Not familiar with that though, but hope you guys enjoyed this video, and I'll see you guys in the next tutorial.